Hey guys, welcome back. We were dealing with the reactions of different acids with metals, rather, we have written those. And I have just told you that organic acids are weaker acids as they have lesser ability to release hydrogen ions. They partially ionize, you may consider, you may say they partially ionize and not fully ionized to give hydrogen ions in water. So that's why they are considered as weaker acids. Right now on this page, we have just written a heading for the next topic, and that is ionization equations of acids. This is the key, this is one of the key towards the reaction understanding of acids. So right now we can say this thing, that what is ionization equation. First of all, one should know this thing, that what is ionization equation. An equation in which a compound converts itself converts a compound converts itself into its ions. Okay, so that is called as ionization equation. So right now we are writing the ionization equations of acids. Okay, so let's see what about the HCl. It is the first acid, and HCl is going to convert itself into its ions. What are those ions? One is H plus and the other is Cl1 minus. What is H2SO4 giving you? It is giving you two H plus ions, H plus ions or H plus 1 ions, and then SO4 2 minus. Okay, so in this way, we can say that these are the ions from these two acids. Let me write down their names as well. This is called as chloride ion, whereas the sulfate is this, and that is SO4 2 minus sulfate ion. Okay. Let me change the board. I am telling you another example. It is of HNO3, that is called as nitric acid. It is converting itself into H plus 1 plus NO3 1 minus ion. And there is another example, that is H3PO4 phosphoric acid. It is giving you 3H plus 1 plus PO4 3 minus. Okay, so this is called as nitrate ion, and the PO4 3 minus is called as phosphate. Okay, so this is called phosphate. And if you will keep that radicals list in your mind, which I have discussed with you in the chapter of bonding, things can become easier for you. And now I'm going to write down the equations of ionization for organic acid. For example, HC double bond OOH. Okay, what is this? This is called HCOOH, and this is methanoic acid. Okay, guys, at this stage, as far as we are not studying organic chemistry, as far as we are not starting organic chemistry, it is an organic acid, so it can create a confusion in your mind. But I would like to inform you that meth is a word which is representative of those organic compounds having one carbon atom. So here is one carbon atom in this compound, that's why it is called as methanoic acid. One more thing is this, that all acids which are organic in nature, their names are ending at the word oic, oic. Okay, so methanoic, ethanoic, propanoic, etc. Number three thing is this, that this organic acid, methanoic acid, has a this HC double bond OH. So one more thing which you should keep in your mind is that all of these acids have what? These acids which are organic in nature have what? This carboxylic group as a part of their structure. So this you should know, that they have this carboxylic group. We have already discussed that C double bond OOH or COOH is called carboxylic group. Okay, now I am telling you that how it is converting itself into its ions. Wow, there is a different type of arrow here. What is that arrow telling you? It's a reversible reaction, going forward, coming backward as well. So half upper arrow is going forward, whereas half backward arrow is coming, half bottom arrow is coming backward. Okay, so it is now going to convert itself into its ions. What ions it will make? Look at here right now. Let me inform you very clearly. This is the hydrogen. This is the hydrogen, which is the replaceable hydrogen. Okay, so if there are 10 hydrogen, 20 hydrogen, that are not making any difference. It is just the carboxylic group hydrogen which will be released in water. Okay, so what will be the equation here? It will be HC double bond O. then single bond O, and then there is a negative charge on it. As hydrogen ion is gone, so it is this. Okay, so now you can see this thing that here I'm trying to write it with a different color so that you people may differentiate. And what is the name of this? This part is called methanoate. Methanoate ion, whereas the other part is called as hydrogen ion. Okay, so it is just a hydrogen ion, just like the previous one. So deliberately I'm writing so that you people may have a clear idea about that. Let me write down one other example, and that is okay, that is here, and this is for ethanoic acid. It is CH3C double bond OOH. Okay, I would like to write the other formula, other form of the formula. It is not the different formula, it is the same formula, but they have different writing style. There are different writing styles for our formula that we will discuss inshallah when I will teach you about formulas. We will discuss this thing that one thing is called as displayed formula, the other thing is called as molecular formula. So these things we are going to discuss, but not at this spot. But here I'm telling you the other way to write the formula. So what is that? It is CH3 COOH. CH3 COOH is called as methanoic, is called as ethanoic acid, and methanoic acid is at the top, and now it is ethanoic acid. Okay, so now there will be a reversible arrow just like the top, and we are going to mention the same point. Look at here right now. This is with the yellow. Okay, let's take a little bit smaller. Okay, okay. So this is the yellow part, which is the carboxylic group. And out of that yellow part, again, the green part, which is telling you that where is the hydrogen, which hydrogen is the replaceable hydrogen. So now what will be the product? It is CH3C double bond O, and then one O is there with the negative charge, and plus H plus 1. Okay, so this is how we are going to write down the product, guys. What is the name of this? As it is prepared from ethanoic acid, so the name will be ethanoate, ethanoate ion. Okay, so this is how we are working on the ionization equations. So you can see this thing. There is a big thing which you can see over there. Look at the top two arrows. They are moving in the forward direction, and there is no backward. Okay, they are just moving in the forward direction, and story is over. Okay, now what about these two? In these two you can see this thing that it is moving forward and coming backward, moving forward and coming backward. So these two are telling you that they can convert themselves into their ions, but their ions can combine with each other again to give you the molecule back. So their ionization is a reversible process, which is just telling you that this is not happening in that perfect way, in that one direction. It is actually happening in two ways. Okay, so it is not that one direction. It means, I mean to say, they are not moving in the forward direction only, they are converting themselves into the backward direction as well. These ones which are telling you about the reversible reaction. So this is how the reactions of a weaker acid can be shown. Okay, so these are the weaker acids, whereas these are top ones are the stronger acids. Stronger acids, once they convert themselves into their ion, story is over. Whereas when we are talking about the weaker acid, they are converting themselves into their ions, and the ions are converting themselves back to give the weaker acid back. Okay, so these are the ionization equations of the acids. Let's discuss some of the equations of the acids with the metal oxide and metal hydroxide, acid plus metal oxide. Okay, so for example, we are taking the example of copper oxide. For example, we are taking the example of zinc oxide. We can take calcium oxide. We can take barium oxide from group number 2. We can take lithium oxide from group number 1, and the acid can be HCl, H2SO4. Here it can be HNO3. Here it can be H3PO4. Oh, beryllium is left. Okay, it's barium. Barium is left, and here we can take, you may consider CH3COOH. Okay, now what will be the product? Okay, so I should write it in a little bit narrow way so that you people may be able to understand it because the product will be a little bit larger in size, and you can see it is CH3COO whole twice and then Ba, okay, plus H2O, okay. So as it is not very much clear, so I am telling you that first of all it is two times. Now the point is this, that why it will be two times. Guys, can you look at there right now, that what is the charge on this? It is the total charge minus, or is this minus charge on this oxygen? No, this negative charge is on this total thing. So we can say that barium is a part of group number 2. This has to come for two times to compensate the plus 2 charge of barium, okay. I would like to tell you the cross multiplication formula development of this ionic compound on the next page, but let's finish this first, okay. So we can say this thing, that here it is making CuCl2 plus H2O. Here it is going to make ZnSO4 plus H2O. And you can say there is two over there, there is two over there, and it is CaNO3 twice plus H2O, and here it is making Li3PO4 plus H2O. As it is not a balanced chemical equation, so we can write this as a 2 and this as a 3 and this as a 2 here. So this is now a balanced chemical equation. I would like to make these arrows and plus with a different color, so that the things can become more visible and clear to you. So this is how we are writing the equations of different types of the metal oxides and metal oxides and acids. In the next page, inshallah, I'm shortly dealing with you regarding metal hydroxide and acids. Okay. Now the point is this, that why the formula is CH3COO whole twice Ba. Guys, look at here right now. We have discussed this thing in ionic compound. Over there, I have told you how to write down the formula. Okay. Before moving that, I can say that it is a radical. It is a radical. How it is a radical? This was not part of the radicals list. Now, how I can say this is a radical? What was the basic definition of a radical or a polyatomic ion? Polyatomic ion is basically many atoms having some collective charge. This is called as a polyatomic ion. So this one minus charge is not only on the oxygen, rather it is on one carbon and three hydrogens, and then again one carbon and two oxygens. So the collective charge one minus is there, okay. So what we can say, that this has a charge of plus 2. Why? Because it is part of group number 2, and it has a charge of plus 1, okay. No, not plus 1, sorry, it is minus 1. It is and what will be the cross multiplication? Okay, look at here right now. So it will be 2 here and 1 here. And I have told you that whenever a radical has to come for more than one time as a part of a formula, it has to be enclosed in the bracket. As it has to come for two times, so what will be the formula? It will be like this. CH3COO, the whole thing will be in the bracket. 2 times 2 as a subscript. Subscript means it is at the bottom. So 2 as a subscript, and Ba will be written with this. So this is how we can say it is called barium ethanoate, okay. Guys, what will be the name of this? Copper chloride. It is zinc sulfate, and this is calcium nitrate, and this is barium ethanoate, and this is lithium phosphate, okay. So these are the names, guys. I'm writing some specific numbers before the formula of the any of the reactant or the product. So what is that basically? Look at here. Let me tell you that it is the total HCl. It is coming for two times. Why it is coming for two times? Copper is a transitional block element. So whenever the charge on the transitional block elements is unknown, you have to consider it plus 2. Okay. So here zinc is a transitional block element as well. We are considering it plus 2. Calcium and barium both are part of group number 2. So definitely they will be plus 2. But what about lithium? It is a part of group number 1. So its charge will be plus 1. So these are the things which we need to keep in our mind whenever transitional block element is its charge is not mentioned. For example, if it is, for example, let me open the pen. Okay, so for example, if it is Fe, and if it is, we are saying that we have to convert it into its ions, we have to convert it into Fe2 plus. But for example, if they are saying that Fe and then a bracket and then three lines and a bracket close, this is now going to react, for example. So here there are three lines, so we have to consider it as Fe3 plus. we cannot suppose it as Fe2 plus. So I'm telling you about 2 plus is the condition only when the charges are not mentioned. Then it is my advice to take it as Fe2 plus, because all the transitional block elements, the block which is between group number 2 and 3, the transitional block elements, they all lose electrons because they all are metals. So when they lose the electrons, they can lose variable number of electrons to achieve different stability levels, which we will discuss with you in A2 chemistry. But right now I'm just telling you that all of them are collectively commonly, the common number of electrons which they all lose is 2. So they all have a plus 2 type of a charge. So this is common among all of them. Okay, so that's why we are saying that here it will be copper plus 2 and Cl is minus 1. So Cl will come for 2 times to compensate the charge of copper. But the basic point I would like to inform you is this, that whenever you are writing an equation, the equation must be balanced. What is the meaning of a balanced chemical equation? Number of times reactants and products should be equal to each other. If they are not balanced, then examiner can cut your marks. So it is a compulsory thing to write down the balanced chemical equation. Number 2 point is this, that while writing these equations, it is important that you are not changing the formula. So please keep this thing in your mind as well, that while writing the compound, your formula should be balanced. We cannot change the formula. So we cannot say it like that we are balancing, and by during balancing we get so emotional that we have changed the formula. So please be careful about that. Formula will not be changed. Either it is coming for 2 times, 10 times, 4 times, that's another story. But we cannot change the formula. Okay. So now I'm changing the board and I'm changing it to the acid and metal hydroxides. Okay. This is now acid and metal hydroxide. Okay. So metal hydroxide examples are very famous and common is NaOH. Let's write NaOH. Okay. NaOH and then CaOH twice, and then you may write down. Let's write some from transition block. It is FeOH twice, and we are going to react them with this with CH3COOH, and this with, you may consider it with HNO3, and here the reactant can be HCl. Okay, now what will be the product? I'm writing the products. So here the product will be CH3 COONA. Look here, there will be no twice, no thrice. So twice TWICE is the term when with the bracket we have to write 2, and thrice is obviously for the 3. Okay, THRICE. Now the point is this, that Na is a part of group number 1, so it has a charge of +1, whereas CH3COO has a charge of -1. So they are coming in 1:1 ratio. That's why there is no need of bracket. Okay. I'm repeating my words, that whenever a radical has to come for more than one time, it has to be enclosed in the bracket. Otherwise, there is no need of bracket. Okay. Now we can say that along with that, H2O will be formed as well. So this is OH from this and H from this. They are now going to combine with each other to make H2O. Okay. And then here we can say CaNO3 twice, CaNO3 twice plus H2O. Okay. So please, this is 2 here. I'm really very sorry for this 3. It is 2 here. Calcium nitrate. And then it is 2 times. So that's why we have to write 2 for HNO3. We cannot change the formula. We cannot say it H2 and 2O6, something like that. No, no, no. Okay. We have to write down the number of times it is present. Okay. And then what about this? It is FeCl2 along with H2O. Okay. So here we can say this thing, that HCl will be written for 2 times in this case. Okay. So this is how the reactions of the acid with metal hydroxides are happening. Okay. Let me change the board so that I may write down the equations of metal carbonates with acids. Okay. So here metal carbonates and acids. Okay. So as a result, we have already decided carbon dioxide, water, and metal salt is formed. Basically, guys, let me inform you very clearly. Carbon dioxide is a gas which, when it will be passed through lime water, it will turn it milky. So this is the thing which you need to know. if you will solve the ATP paper, you can practice this thing that whenever gas identification test is there, one line is for the test and the other line is for the observation. Okay, and sometimes they can be merged as well. So please be careful about this, that what we have to do while performing a test, that will be in the test line, and what will be our observation, what we are going to see. Okay, what we have seen, that will be the observation. So here it is calcium carbonate reacting with 2HCl. Then it is copper carbonate reacting with 2HNO3. Then it is zinc carbonate reacting with H2SO4. So such type of the reactions are there. It is CaCl2 plus H2O plus CO2. It is CuNO3 twice plus H2O plus CO2. Okay, and then the final is ZnSO4 plus H2O plus CO2. Okay. Now the point is this, that what is calcium chloride? It is CaCl2. Copper nitrate is CaNO3 twice, whereas zinc sulfate is ZnSO4. So these will be the products whenever a metal carbonate is going to react with an acid. Okay. So this is the thing which you people should know, how to write a balanced chemical equation. Okay. Now, whenever metal carbonate is being produced, examiner is sometimes asking that those reactions in which mass is getting reduced, the content mass is getting reduced. This is one of those reactions in which content mass is getting reduced, and why it is so. Basically, those reactions in which carbon dioxide or any other gas is being produced, we can say that mass of the total content is getting decreased. So this is how it is happening. Okay, so now we are going to change the board so that you people may understand the idea of the reactions of acids with ammonia. So this is what we are going to do on the next page. Okay, so it is acid plus ammonia. Guys, it is a salt only, and this is, there is no metal, so no metal salt. Okay, so it is HCl plus NH3, and it is NH4Cl, and then HNO3 plus NH3, and it is giving us NH4, NH4 and O3. NH4Cl is called as ammonium chloride, NH4NO3 is called as ammonium nitrate. And then there is another example, H2SO4 plus NH3, and here it will be for 2 times, and H3PO4 plus 3NH3. So guys, here it will be ammonium sulfate, NH4 twice SO4, and there it will be NH NH3, and then NH3 and then PO4. Okay, so the NH4Cl is called as ammonium chloride, then NH4NO3 is ammonium nitrate, then ammonium sulfate, and the last is ammonium phosphate. Guys, I would like to react this ammonia thingy with organic acid as well. So what is that? HCOOH plus NH3. What will be the product? HCOONH4 plus H2. No, there is no H2 in this case. Remember this thing. Why it is? So I have just told you that they are going to make one product. Okay. So they are combining with each other. This hydrogen and this NH3. So as a result of that, they are making NH4 at the end. Okay. So please keep this thing in your mind very clearly. Okay. Then it is CH3, COOH plus NH3. So as a result of that, what will be the product? It is CH3, COONH4. Okay. So the top one, this is called as ammonium methanoate, and this is called as ammonium ethanoate. So this is how the reactions of acids are occurring with metals, with metal oxide, metal hydroxide, metal carbonates, and the next is with the ammonia. And one more thing which you should know is this, that what are the ionization equations? That all are done. that's a big thing for you to understand it. At this stage, it will be quite very helpful to understand the basic concepts of the reactions. After this whole thing, I would like to teach you the next topic, and that will be of bases. Okay, so in the next class, inshallah, we are going to start the topic of bases. Bases. Okay, basis, and further we will continue this chapter till all the concepts are being done in detail. Thank you very much, guys. Take care of yourself.